Welcome, folks. And this is Mr. Moore from St. Emily School here once again, looking at today a MathUp common task. And our MathUp program is one that we use a lot. While obviously within Ottawa Catholic School Board, it is our main math program and one that we've been doing for more than a year now, almost a year and a half at St. Emily's. And so I just wanted to walk you through very quickly a little bit what that looks like. We're going to start with today with additive reasoning. Now, additive reasoning is kind of that basic, that first level that we look at from a junior math standpoint. Following that, we get into multiplicative reasoning, and then finally proportional reasoning is again kind of the higher level. If you think in terms of that hierarchy, additive is kind of at the bottom, then you have your multiplicative, and then your proportional is up at the top. So we're going to start right with the basics, looking at additive reasoning. And our common task, I've already downloaded and has brought up. And you can see it says, solve one of the questions in 3 different ways and show how they are different. And so we have 4 choices here. A is 80 minus 14, B is 5.2 minus 1.48, and C is 10 minus 3. And then D is choose two-digit numbers and subtract them. And so we actually have multiple entry points depending on where the student's additive reasoning is at. Obviously, if we look at these 4, the 10 minus 3 is probably the simplest one. The B 5.2 minus 1.48, to be able to show that in different ways is probably going to be the most challenging one. So we're going to pick one kind of in the middle. But what you might notice here is all 4 of them are actually subtraction problems, and we said this was additive reasoning. Well, the reason this is still considered to be additive reasoning is because once we get into our higher grades, we understand that subtraction is actually just adding negative numbers. And so in this particular case, if we look at A, we know that this could also be read as 80 plus a negative 14. And so by thinking in those terms, where we're going to take the 80, the positive 80, and we're going to add a negative 14, we're going to come up with our answers. So how could we accomplish this? Well, the first one is we can certainly always use manipulatives. Being at school, we would normally use some chips or counters to add. At home, these things may not be readily available to us. So I'm going to get a little bit creative here, see if I can get my camera to work properly. And what I've got is, I got a bag of kidney beans and a bag of chocolate chips. And of course, with my chocolate chips, I always get a treat at the end where we can make some chocolate chip cookies afterwards if we so desired, or we can use our kidney beans as part of our chili for supper as well. So these are all household items that some folks might have. I've also used on occasion, grabbed a box of Kraft or KD and used the noodles out of them to serve as my counters. So the reason I have 2 though is because first of all, I am going to do this as base 10. And so I'm going to start off and I'm going to open up the kidney beans. Now, I got a lot of kidney beans here. So I'm actually going to use these as my ones. So I'm going to count them out here if I can get my angle right. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll start with that. And so my 10 kidney beans are going to represent 1 chocolate chip. And so my 1 chocolate chip is actually my base 10 with a value of 10. So my chocolate chips are my 10s, those are my 1s. And so it starts off and it said that my first number is 80. And so I'm going to begin, and I guess I'm going to get 8 chocolate chips. 1, 2, 3, 4, 5, 6, 7, 8. I always like to lay them out in grid to make it obvious about how many I have. This also lends itself to multiplicative reasoning as well, because I also know that 4 times 2 also gives me 8 in this case. And as I can see, by moving them in that fashion, doesn't change anything. And so that actually lends itself to my next level, but we'll start with there. So there's my 80. And in this particular case, they want me to subtract 14. So what I'm going to do is I'm going to pull my 10 out of the 14 first, and that leaves me 4 that I still need to subtract. So I'm actually going to do my substitution now. So I'm going to take that other chocolate chip out, and I'm going to use my 10, and now I'm going to pull those 4 out. And so as you can see, there's my 14, 10, 14, and I'm ready to count. So what do I have left? 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66. And so in this particular case, my answer is going to be 66, is one way of showing how I can do this. Now, what's another way that I could show that? Well, obviously an easy way to accomplish that is with a number line. And with a number line, I'm simply going to hop up to my top here, and I'm going to put in images. I'm going to go to images. We'll see if my internet's working for me. Hopefully it is. And I'm just going to put in 100 chart. And for these purposes, click on any one that I have. I'm going to scan down, and there we go. And so in this particular case, now I've got my 100 chart. I'm just going to work off of here. And so because I understand, again, that this is 80, so my starting point in this problem is going to be 80, and I want to add negative 14. I'm going to count down using this as a number line. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've counted down my 14, and I end up again with an answer of 66. And then finally, one other way is I can certainly always draw this, and a whole bunch of different ways of how I can accomplish that. But in this particular case, what I'm going to do is I'm just going to hop over to my Smart Notebook. And again, because I'm dealing with a large number such as 80, I'm going to use my base 10 once again. And so by using my base 10, I can certainly do it as tallies. If I want to take my marker here, use my marker, use my pen, I can certainly draw as so. But I don't want to do 80 of these. That's way too much work. So in this particular case, what I'm going to do is I'm going to use my eraser, and I'm going to use shapes instead, I think. And so I look at this and I see, oh, I've got an octagon up here. An octagon, that's going to lend itself really nicely. So if I take my octagon, and I'm going to put 1 there. So there's my 8. Well, how many of these octagons do I need? Well, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. And so again, you can see I'm using my multiplicative reasoning as part of my additive reasoning. And so I know that I've got 80 sides in this now, so I can actually just count off that. So if I do this, I'm going to hop up to my pen, and I know I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What do I have left? Well, I know that I've got 8, 16, 24, 32, 40, 48, 56, 64, 65, 66. And so I've got 66 sides left in this particular case. And that, once again, gives me my answer of 66. And so that's 3 different ways of how I can solve this particular problem using number 1. And you could almost describe this as, in however you want to describe this, visual design. I wouldn't quite call it a pictograph, but it's kind of along those lines, but certainly a visual drawing of some type in terms of solving this. You could also say that on our second example, we used a number line. On our first example, we used base 10 using materials that we have around the house. So hope that helps, folks. We will continue on in future days looking at some other MathUp problems. Thank you. Bye-bye.